Assalamualaikum. My name is Mohd and my metric number is 71327. So today I'd like to share a brief about insightful analysis on port turnaround time, one of the most important indicator of port efficiency. Our study focused on measuring the time vessels spend in port from arrival to departure, which is known as the turnaround time or TAT. This metric directly impacts how competitive and efficient a port can be in today's fast-paced, globalized economy. Shorter turnaround time mean faster cargo movement, lower costs for shipping lines, and better service for customers, all of which are crucial for port to stay competitive and support global trade. Conversely, longer turnaround time can cause delays, congestion, and increased operational costs. To understand this better, we collect data on TAT from 30 ports around the world, covering key regions like Asia, Europe, and America and Africa. The data come from the Bureau of Infrastructure, Transport, and Regional Economic. In our analysis, we apply statistical tools including descriptive statistic, histogram, box plot, and normality test, and confidence interval analysis. This method helps us evaluate whether each port is operating within acceptable efficiency range and identify potential area for improvement. Some notable findings from our data show that Port Klang in Malaysia and Lion Chabang in Thailand have some of the fastest turnaround time record at just 11 and 12 hours respectively. On the other end of the spectrum, ports like Durban in South Africa with 72 hours and Los Angeles at 61 hours show much longer duration that indicate potential inefficiencies. Ultimately, this analysis isn't just about numbers. It's about providing actionable insight that can help part reduce delay, improve resource allocation, and enhance service delivery for all stakeholders involved, including shipping companies, port operator, and customer. By leveraging this finding, ports can make strategic decisions that contribute to smoother, faster, and reliable maritime logistic operation. That's all from me.
Assalamualaikum and hi everyone. My name is Wahidah binti Nawi and my metric number is S70353. And as for my part, I will explain about the key descriptive statistics of port stay duration. So, what is descriptive statistics? Descriptive statistics help us to summarize the large amount of data to see the patterns or the variations. And in this case, we analyze port stay duration to understand how long ships in port stay, whether there are any delays or outliers. Now I will explain about the key measures from our descriptive statistics measured in both hours and days. This data includes 30 ports, and we calculated several important values to understand the overall pattern of how long ship stays at port. So as you can see the table here, the mean or average stay is around 30.23 hours, which is about 1.22 days. And the median or the middle value is slightly lower at 26.5 hours, showing that more than half of the ports complete operation in just over a day. And the minimum stay is just 11 hours, while the maximum is 72 hours. That equals to 3 full days. Okay, which indicate a strong outliers that could point to delays or inefficiencies at certain ports. And the standard deviation is 11.20 hours, indicating a moderate speed in the data. This means port stays vary, but many are still close to the average. And looking at the interquartile range from 25th percentile Q1 of 22 hours to the 75th percentile Q3 of 37 hours, we can say that the middle 50% of port stays are within this range. And overall, these statistics help us to understand not only the average stay, but also how consistent or varied the port operation are across the different locations. That's all from me. Thank you.
My name is SOFEA binti Mohd TAJUDIN. My TIN number is 71525. So my part is visual data. We do visual data to better understand the history of port stay duration. So we have two graphs, which is histogram and port plot. Firstly, we have histogram graph. We have 7 turnaround time. You can see the graph. The higher frequency for this graph is 21 until 30 turnaround time, which is 11 number of port. So we can conclude that the highest is 11 port. Second is port plot graph. We start from the left. You can see the graph from the left. Firstly is minimum, which is 11. Second is lower half, is 22. Third is medium, 37. Fourth is upper half, 37. Lastly is maximum, 72. So that's all from me. Thank you.
Hi everyone, my name is NORIZZATI. Metric number S71369. Now I will explain our analysis of the 95% confidence interval for port turnaround time. For a sample of 30 vessels, we found the average port stay duration to be at 30 hours and 23 minutes with a standard deviation of 11.2. Using this data, we calculate the standard error, which come out to 2.045 using a Z value of 1.96 for 95% confidence. We calculate the margin of error to be approximately 4.008. Therefore, our confidence interval range from 26.222 to 34.238 hours. This means our 95% confident that the true average turns around time for all vessel lies within this range. Since the interval crossed the 30 hours benchmark, we cannot say that it's certain whether the part is meeting our exit the efficiency standard. It suggests that while performance may be acceptable, there's room for operational improvement to consistently stay below that target. I think that's all from me.
Assalamualaikum and good day everyone. My name is Muhammad bin MAHADI. My matrix number is S70424. Let's begin by looking at the data analysis and descriptive statistic of our study on port turnaround times. We collected 30 observations and representing the time vessels spent at the port from arrival to departure, measured in hours and converted to days for comparison purposes. From the analysis, we found the mean turnaround time is 30.23 hours or around 1.22 days. This is slightly above the industry benchmark of 30 hours. The median, which is the middle value, stands at 36.5 hours, and the standard deviation is 11.30 hours, indicating a moderate spread of data. The minimum turnaround time recorded was 11 hours, while the maximum was 72 hours, giving us a range of 61 hours. The 35th percentile of Q1 is 32 hours, and the 75th percentile of Q3 is 37 hours, which helps us understand where most of the data lies. Overall, this suggests that while the average port turnaround time is near the benchmark, there are some ships that experience significantly longer port stays, which may impact overall efficiency. Moving on to the second part, we use data visualization and statistical tests to gain deeper insights. First, the histogram shows that the majority of vessels, about 11 out of 30, have turnaround times between 31 to 30 hours. There are a few vessels with much higher durations, even up to 72 hours, suggesting possible outliers. The box plot supports this. The median is at 27 hours, and we see that most of the data lies between 22 and 37 hours. However, with the maximum at 72 hours, there is clear evidence of upper end delays, possibly due to operational issues. Next, we tested the normality of our data using the QQ plot and the Shapiro wheel test. The QQ plot shows a curve in the upper tail. and the Shapiro-Wilk test gave a p-value of 0.0139, which is less than 0.05. This means the data is not normally distributed and is right skewed, showing some extreme delays. Finally, we calculated the 95% confidence interval for the mean. It ranges from 36.32 to 34.34 hours. Since this interval crosses the 30-hour benchmark, it means we cannot say for sure whether the pod is truly operating above or below the ideal efficiency level. Some days it might be within reach, but on others, delays can push the average higher. In conclusion, these insights help us understand the variability in pod performance and the need for targeted improvement. That's all for me. Thank you.
Hi, my name is Mohd HAKIM ZULKAPELI, metric number S72119. So let's continue for interpretation of result, which have three main ideas. First one, interpretation of mean turnaround times. Second one, statistical distribution insight. And last one, confident interval interpretation. So let's begin with the mean turnaround time, which stand at 30.23 hours. This value marginally exceed the industry benchmark of 30 hours for efficient port operation. While the difference may appear negligible over hundreds of vessels calls per month, such a deviation can result in significant cumulative delay. The current mean indicates that the port is functioning at the edge of efficiency without adequate the buffer to accommodate unexpected disruption like weather event, labor shortage, or equipment malfunction. Next, the median turnaround times is 26.22 hours, quite close to the means. This suggests a fairly symmetrical distribution of data with limited skewness and minimal presence of extreme outliers. Such symmetry is a positive indicator, suggesting that most vessels are processed within a consistent range of time, and operational performance is reasonably stable across different shipping scenarios. Moving to the confidence interval, at 95% confidence level, the average turnaround times is estimated to be between 26.22 and 34.24 hours. Since this range crosses the 30 hours benchmark, we cannot statistically conclude that the port is definitely over or under the industry standards. Therefore, while some inefficiencies exist, the performance level is still within an uncertain zones. A larger data set would be required to narrow the interval and improve the precision of this estimate. Next is operational recommendation overview. Despite the lack of statistical significance, the fact that the upper limit of interval surpasses 34 hours indicates that certain vessels are indeed experiencing operational delays. From a management perspective, this uncertainty demands a proactive approach. Rather than waiting for performance to decline, the port should implement preventative measures to maintain competitive service levels and reduce the risk of supply chain disruption. Furthermore, optimizing scheduling and resource allocation to address potential inefficiency, the first recommendation is to enhance scheduling and resource allocation. By integrating dynamic berth and crane assignment system, the port can adapt to real-time changes in vessels' arrival, cargo types, and terminal activity. Predictive tools would also allow operations manager to anticipate delays due to heavy traffic or unusually large cargo loads, that allowing for proactive rather than reactive adjustment. The last recommendation is digitalization of clearance and documentation, which administrative delays remain a key bottleneck in ports operation. By digitalizing clearance process, particularly through electronic data interchange and linking with customs system, the port can significantly reduce the time required for approvals and documentation. Ideally, much of the paperwork can be completed before a vessels arrive, ensuring smoother transition at the berth and quicker turnaround. The conclusion is, based on our analysis, the port's average turnaround times is 30.33 hours, just above the 30 hours efficiency benchmark. While the confident interval shows statistical uncertainty, some vessels still face significant delays. This indicates the port is operating its limits without a safety buffer. To address this, we recommend enhancing resource scheduling, standardizing operations and digitalizing clearance process, and implementing a real-time monitoring. This target improvement can shift the port from borderline performance to consistently efficient operation and ensure long-term competitiveness. That's all from our group. Thank you.